Hello, I've had a question about my denoising filter on the forum. So rather than trying to write it all down and explain it in technical language that I don't understand, I'm going to make this video and hopefully explain what is going on. So firstly, it is based on a patched base denoising filter like non-local means. The exact implementation I'm not sure of because it's built into the gmic, and so I don't know any of the internal details, but it is definitely patch based like non-local means. And I'm going to cover the transforms from the shadows and lights sliders first, because I have this conveniently here. So as you can see, gamma is gamma. Light, hang on, let me just reset that so it's just so light produces this kind of curve, and shadow does exactly the same kind of curve, but for the shadow region. Right, so the next thing we can do is go through the algorithm, and I can try and explain it. So I've actually made some changes to the filter since the last video, and this is just going to give you a preview through the stages. It's pretty much the same stages, it's just some minor changes. It's all basically the same. So at the beginning we have the image to be denoised and a guide image. The guide image is affected by the gamma and shadow light controls, and oh, lost the, there we go. And the we can change the saturation, and if we increase the amount of noise reduction we want in the shadows, then the shadows becomes less contrasty, and so more noise reduction is done there. So the next step is decomposition. I do that by resizing it down by 1/3, and so we have the fine noise on one scale. Let me back up a wee bit. So I do the denoising on the full resolution, downscale it, and pull out the high frequencies that I need to put back later, and I do that 3 times, so for fine, mid and large. So if I adjust the large noise reduction, you can see that it's working on this scale, and if I go to the mid scale there, you can see that's the high frequencies that have been pulled out for the recomposition, and there's the mid scale, and obviously the other scales don't affect that scale, although there is a little bit of bleed through from the fine, the upper scale to the next scale. So the fine denoising does denoise some of the mid scale as well. Right, so what's the next step? We're looking, I can't remember what. of course, we need to have the recovery switched on. So once the patch-based denoising has been done in the multi-scale and it's been recombined, then I get the difference between the denoised image and the original image, and that gives us the basis for doing the recovery. So if we do way too much noise reduction, you can start to see the features come through in the difference between the denoised and the original image. So from there, what do I do? Right, so there I take the absolute value of the. Now let me explain what I'm doing first. So I want to scale normalize the level of the noise across the image before I do the detail recovery, which I'll explain a wee bit more later. But I do that in well, I hope is a smart way. So I find the absolute value of the difference between the original and the noise. I then smooth that. I smooth it, but that's guided by the denoised image. So now what we have is a map of noise intensity. So obviously in the darker areas here there's more noise, and in the lighter areas down here there's less noise. So I use that to normalize the level of noise across the difference image. So I've just blurred that a little bit so for the demonstration so you can see it easier. So there, I think that's the I can't remember what steps I put in here to show you. I think that's not normalized, and that is normalized. So the level of noise in different areas of the image is approximately the same, and that's based on the areas that we got from the smoothed image. Sorry, the smoothed absolute value. Now the reason I'm doing that is because the recovery is tile-based recovery. So I break the image down into individual tiles. You can probably see the outline of some of the tiles there. Yeah, so they're 64 by 64 pixel tiles. But so for each tile, I do a fast Fourier transform, and then I use a threshold to determine what is noise and what is not noise. That threshold is the median value of all of the tiles. So the reason I need to do the normalization step is so that each tile has the same level of noise and is not going to screw up the finding the noise estimate from all of the tiles. So I do a Fourier transform on all of the tiles. I find the median value of the Fourier transform. I use that as the threshold to determine what is noise and what is noise, and the recovery amount is an adjustment of the threshold once I've determined it from the median of all the tiles. Now, so the next step is to undo the normalization, and this is useful. What the other useful thing about doing the normalization is that you can see in this image is that it reduces the level of noise down to it reduces the artifacts that you can see because it's denormalized it, which means some of the artifacts actually get reduced from the denormalization. So in these light areas, you can see there's some ringing artifacts and so on, but when we undo the normalization, you can see all of that sort of stuff is reduced. So that's helpful for that reason as well. The difference between the fast recovery and the slow recovery is the slow recovery does the recovery on offset images, so it has the effect of effectively offsets, does the detail recovery 5 times, but all of the tiles are offset in a randomish pattern that I kind of worked out by trial and error, and that and then all of those 5 detail recovery steps, I find the median of all of those. So that means that the signal being recovered has to appear in most of the recovery of those 5 recoveries. So I'm just going to switch back to the fast recovery. So you can obviously see in the difference between the fast recovery and the slow recovery when you're just looking at the recovery is it's pretty obvious. You can see all kinds of problems with it, like one. So we've got a curved line here, which if I adjust that a little bit, you can see the outline of the tiles, and what it's done is it's actually made that curved line into a series of straight lines. Now if I do the slow recovery, that eliminates a lot of that problem, because of each tile is at a slightly different offset, and so you end up with a much smoother curve there. That's the recovery, and then once that's recovered, of course, the final step is to add the recovered information back into the original image, the denoised image, sorry. And so that ends up recovering the fine patterns in the image. So that's pretty much it. So I'll end it there, and I hope that's answered your questions. If that just means there's more questions, I'll see if I can answer those as well.